I am doing stock market prediction and forecasting using stacked lstm. For this we import pandas, then upload the dataset through pd.read.csv, and we have to print that dataset by the use of df, whatever the variable name in which we stored. There are 135 rows and 8 columns. Through head command we used to see the top 5 elements of the dataset. We can take close column. By doing this we can get all the close column. See, there are all our close columns value. Then we want to see the shape. There are 135 records, and we want to plot the dataset by using matplotlib. That is my graph. lstm TM are sensitive to scale of the data, so we apply mean max scalar. Input numpy, and we want to see our close column in which we store, that is df2. Then from sklearn pre-processing import mean max scalar. We are going to take feature range from 0 to 1. Then we want to see the shape, that is 35,1. df2 is now converted into array. Now we want to splitting the dataset into train and test split. My train size is 65% of the total length of my dataset, and this is the training size. My test size is the difference between the training size and total length. We see the training size and test size. Then we see the train data. Then create dataset, and we take timestamp equal 1. Here by default whatever we have to take in timestamp, it will be that we have to take in 100. We have 100 features. Then print x train data. Next step, creating a stacked lstm model. Before doing lstm, firstly we should reshape the x train into 3D. X train shape 0, x train shape 1, that is all written in 1, and we have to lastly use 1, that is the 3D, 3-dimensional. Create the stacked lstm by using import sequential from TensorFlow Keras model, dense from TensorFlow Keras layer, lstm from TensorFlow.keras layer. Then we have to use sequential. Then add lstm50 return sequence is equal to true, input shape 100,1. Add lstm50 return the sequence is equal to true, add lstm50, then add temps is equal 1, then compile mean squared error. And we use optimizer, that is Adam. We have to wait for some time to execute in the cell. My cell is executed without giving any error. Then fit the model. It takes some time, so we pause the video, and after executing I restart that. See, there are 100 stamp because I have taken 100 time stamp. Value of loss, that is given here. My cell is executed totally. There are 99 from 1 to 100 epoch, because I have taken epoch size 100. Let's import TensorFlow. And then we have to take version and let's do the prediction and check the performance metrics. Then we do the scalar inverse transform because we have already scaled that. Now we have to do scalar inverse because I need to find the RMS E performance metric, that is root mean square error performance metric. Train predict. Now this is how we predict the data. I have to take a NaN value, whatever train predict and test predict I have gotten, that I am just plotting it here. That is my graph. Then check the length of test data, that is 713. I have to take in 613 because I have to predict previous 100 data I have to take in for predicting future. That is my temp input. We are converting into less the temp input. We are passing to this model and reset them. We are doing prediction, then y hat value and adding y hat value to final output. And adding y hat value to final output and also adding to my previous input. This will go for 30 loops. I'm using while I is less than 30 and I is equal to 0. That will for going for 30 loops. This is my output. And in day prediction we have to take 30 values because we have to predict 30-day future. This is my plot. Actually this is my graph in which the straight that orange line represent the 30 days value, and this is my stock market prediction graph. Thank you, and this is my all code and output. Respect.